Okay, simple shapes video number 2 because the first one didn't work. I'm going to go a little bit faster. There's some simple shapes. You have them on your sheet. Check this out. This shape right here is a linear. Here's an example that could be a linear shape. HCl. See how this is linear? That could be the H and that could be the Cl. This shape is also polar because it has two different ends. Okay? Now let's look at another linear shape. What if we had something like this and it was linear? All right, I'm going to cover that up. Here's an example of this shape. This shape could be like Li2O. See, this crosses the stairs, so it's going to be two-dimensional. So that's how it's going to be linear. Let me make it a perfect line, all right? So a linear shape that crosses the stairs, if it crosses the stairs like this, it's going to be linear, okay? This is two-dimensional, and this is non-polar, because if you look, both ends are the same. Now let me show you another exception. What if I made it water, H2O? Then now it is not crossing the stairs. It's a molecule. It's going to be like that. Now it's bent. Things that cross the stairs, if at all possible, become three-dimensional. All right? And this one's also polar because it's got a top and it's got a bottom. Does that make sense? The top is different than the bottom. I can hold it up like this, boop, and I can hold it up like this, boop. Two different ends, okay? Let's move on. Let's try some more shapes. How about something like aluminum chloride, AlCl3. Does that cross the stairs? Yes, so it's going to try to be 2D. Al, boop, 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 boop. And it's going to be two-dimensional. So this is a triangle. Yeah, it's trigonal, but it's also planar. So that would be trigonal planar. Let me ask you a question. Does this have any different ends? No. Let me build it and prove that to you. Here is a look. Well, where'd all my toothpicks go? Here I am flying through this. Oh, here, I'll grab another one right here. Boom, flying through this. Bam. There. That is trigonal planar. And it is also nonpolar because all of the ends are the same. It fits on one plane. Let's try one like, how about NH3? Now we're going to change it. NH3 does not cross the stairs, okay? So it's going to be three-dimensional, and it is going to stand up like this. Why would it stand up like this? Because there are unbound electrons on the top pushing down. So this is now no longer planar. It's a three-dimensional object. It's a trigonal pyramid. Let me get this information off the screen now, right? This is a trigonal pyramid. If we were going to draw this, we would say N, H, H, H. Now in college you wouldn't necessarily draw like this, but I want you to draw it like this to me so you can remember that it's trigonal pyramidal. It's still got a triangular shape at the bottom, but it also stands up. And is this polar or non-polar? Well, the thing is polar because it's got a top and it's got a bottom. They're different. Look, this thing is polar. It's got a top and it's got a bottom. Whoop, lost my little thing there. And it's got a bottom, right? So those are some simple shape. It's a simple shape for you. You got a little assignment. I'm going to post this to YouTube and there.